Step number 1, logs on one side, everything without a log to the other. Check. Step 2, simplify all down into one log, make it smaller. Check. Step 3. Step 3. Well, there's a step before solve. Convert to exponential. Why do we do that? To get rid of the log. It's the only way to make a log disappear. So 2 goes over, not sorry to the 3, log disappears, x stays where it is.
Is exponential form and exponential notation the same thing?
Yes.
Yes.
Step number 4, we just solve like we usually solve. 8. And the very important special equation, step number 5, is check. There's no work to be shown. This is a mental activity. You're just putting in 8 and seeing if it turns whatever there is negative. In this case, we're good to go. Answer is 8. Method box. Step 1. Simplify would be step 2. Move logs to one side and so if logs are on one side, what's on the other side? Numbers could be constants, could be variable. I call them non-logs, so stuff without a log. Non-logs to the non-logs. That's an O. Step 2, simplify using. That's too specific, just general, we call them log laws. Remember, blah, blah, blah. So when we're simplifying, coefficients become exponents. Adding becomes. Subtraction becomes. How do you know when you're done simplifying? How do you know when it's enough simplification? 1 log. We're down to 1 log, 1 base. Second step, solve. My job would be easier if that was just the step for every kind of equation. Step 1, solve. I'm down to red pen for the very important last step. Check for negative or 0 logs. Bad. Out of the last, 12 years of provincial exams, all but 1 has had a question that the answer doesn't work in the end. Because they want to know if you're checking it. Can I move it? Example 2. Okay, let's step it up a bit because that first one was way too easy. Yeah, no, you're ready for this. 5 equals log base 2x plus log base 2x. Oh, you're so ready. Yeah, just solve. Step 1.
Could you graph it?
This would probably be on the non-calculator section of the exam. So yes, if you could graph this without a calculator.
Oh, I can.
Okay, step number 1. all the logs on one side, everything without a log to the other.
That's already done.
Already done. Step 2, simplify using log laws. Adding means we're going to multiply. So we're smushing this down, we're simplifying it, we're making it smaller, we're turning it into one log, one base. We're going to take x and multiply by 2x, which gives us 2x squared. Adding became multiplying. How do we know when we're done that step? How do we know when we have simplified enough to move on? One log, one base. Step 3. What's going to move? Ooh, what's going to move? The base of 2. Because the base comes over, 5 moves up. What happens on the other side? Log disappears, and 2x stays. So we get 2 to the 5 equals 2x squared. Can we evaluate 2 to the 5? So 2 times 2 times 2 times 2 times 2. This is quadratic. How many ways are there to solve a quadratic? They are factoring, square root, completing the square, graphing, quadratic formula. Which one would you like to do? I would not want to factor. I would want a square root because we don't have an x. We just have an x squared. So let's get rid of the 2. Oh, what goes in front of the square root? Very special step number 5, we check. So if I put minus 4 in here, not good. Well, what if I put it here? Not good. Let's check 4. Correct? Good to go. If you go to check and it works in one, for example, but doesn't work in the other, it's gone. If it doesn't work anywhere, we cross it out. You can't not put it. So if you went from x squared equals 16 to 4, I don't know, did you know negative 4 was an answer and you crossed it out, or did you forget there was those 2 answers? So you have to show it and you have to cross it out. What do we call this kind of answer that we end up crossing out? Extraneous root. No. Just when your professor next year talks about it, you won't be like, what? What's happening? What I love about these equations is the same 5 steps are going to work every single time. There's no exceptions, there's no tricky ones, there's no rules. It's the same 5 steps every single question. Okay, take a look at number 3. Lots going on here. After the first one, we assume the directions are the same. This is impressive math. This is really smart people math. If you have younger siblings, you call them over when you're doing this homework, they'll cry. They'll think you're the smartest person on the face of the planet. Show this to an essentials kid, it's not going to go well. Step number 1. Logs onto one side, numbers on the other. So what needs to move? This one. Here's how I'm going to cheat and not have to rewrite the whole thing. So if you're lazy, you might want to pay attention. I'm going to move the equal sign here, and what am I going to put in front here? There's a way to cheat. Okay, lots of logs on this side. So we start with coefficients. Are there any coefficients? 2, and coefficients become? Now anything that's adding becomes Multiplying, anything that's subtraction becomes division. Or anything that's positive goes on the top, anything that's negative goes on the bottom. So we're going to smush this down into one log. X squared on the top or the bottom? X plus 2, top or bottom? 2x minus 3, top or bottom? A common mistake is people will want to take the negative with it. What happened to these negatives? Yeah, they disappeared because we ended up dividing. That's steps 1 and 2. Check, check. Step 3. Okay, what's the base that we don't see? What happens to the 0? What happens to the log? Disappears. What about all that crap in that fraction? Stays exactly where it is. Oh, that came too fast. We'll finish after lunch, though that makes me sad.